Okay, hi everyone, welcome back to this video series on cryptocurrency. Hash time lock contracts, HTLC. Payment channels can be further extended with a special type of smart contract that allows the participants to commit funds to a redeemable secret with an expiration date. This feature is called a hash time lock contract, or HTLC, and is used in both directional and routed payment channels. Let's first explain the hash part of the HTLC. To create an HTLC, the intended recipient of the payment will first create a secret OR. Then they calculate the hash of this secret H equals hash OR. This produces a hash H that can be included in an outputs locking script. Whoever knows the secret can use it to redeem the output. The secret OR is also referred to as a pre-image to the hash function. The pre-image is just the data that is used as input to a hash function. The second part of an HTLC is the time lock component. If the secret is not revealed, the payer of the HTLC can get a refund after some time. This is achieved with an absolute time locking check lock time verify. The secret implementing an HTLC might look like this. If you have the secret or hash 160H equal verify, else refund after timeout lock time check lock time verify drop pay public key check sig end if. Anyone who knows the secret or when hash equals to H can redeem this output by exercising the first clause of the if flow. If the secret is not revealed and the HTLC claimed after a certain number of blocks, and the payee can claim a refund using the second clause in the if flow. This is the basic implementation of an HTLC. This type of HTLC can be redeemed by anyone who has a secret OR. An HTLC can take many different forms with slight variations to the script. For example, adding a check sig operator and a public key in the first clause restricts redemption of the host of the hash to a named recipient who must also know the secret or. Routed payment channels. Lightning Network. The Lightning Network is a proposed routed network of bidirectional payment channels connected end to end. A network like this can allow any participant to route a payment from channel to channel without trusting any of the intermediaries. The Lightning Network was first described by Joseph Poon and Thaddeus Terra in February 2015, building on the concept of payment channels as proposed and elaborated on by many others. Lightning Network refers to a specific design for a routed payment channel which has now been implemented by at least 5 different open source teams. The independent implementations are coordinated by a set of interoperability standards described in the Basics of the Lightning Technology Bolt paper. Prototype implementations of the Lightning Network have been released by several teams. For now, these implementations can only run on testnet because they use SegWit, which is not activated on the main Bitcoin blockchain mainnet. The Lightning Network is one possible way of implementing routed payment channels. There are several other designs that aim to achieve similar goals, such as T-Chan and Tumblebit. Basic Lightning Network example. In this example, we have 5 participants: Alice, Bob, Carl, Diana, and Eric. These 5 participants have opened payment channels with each other in pairs. Alice has a payment channel with Bob. Bob is connected to Carl, Carl to Diana, and Diana to Eric. For simplicity, let's assume each channel is funded with 2 Bitcoin by each participant for a total capacity of 4 Bitcoin in each channel. Figure 12.9 shows 5 participants in a Lightning network connected by bidirectional payment channels that can be linked to make a payment from Alice to Eric. Alice wants to pay Eric 1 Bitcoin. However, Alice is not connected to Eric by a payment channel. Creating a payment channel requires a funding transaction which must be committed to the Bitcoin blockchain. Alice does not want to open a new payment channel to commit more of her funds. Is there a way to pay Eric indirectly? Figure 12.10 shows a step-by-step process of routing a payment from Alice to Eric through a series of HTLC commitments on the payment channels connecting the participants. Alice is running a Lightning Network L node that is keeping track of her payment channel to Bob and has the ability to discover routes between payment channels. Alice's LN node also has the ability to connect over the internet to Eric's L node. Eric's L node creates a secret OR using a random number generator. Eric's node does not reveal this secret to anyone. Instead, Eric's node calculates a hash H of the secret OR and transmits this hash to Alice's node. Now Alice's LN node constructs a route between Alice's LN node and Eric's LN node. The routing algorithm used will be examined in more detail later, but for now let's assume that Alice's node can find an efficient route. Alice's node then constructs an HTLC payable to the hash H with a 10 block refund timeout, current block plus 10 for the amount of 1.003 Bitcoin. The extra 0.003 will be used to compensate the intermediate nodes for their participation in this payment route. Alice offers this HTLC to Bob, deducting 1.003 Bitcoin from her channel balance with Bob and committing it to the HTLC. The HTLC has the following meaning: Alice is committing 1.003 of her channel balance to be paid to Bob if Bob knows the secret, or refunded back to Alice's balance if 10 blocks elapse. The channel balance between Alice and Bob is now expressed by commitment transactions with 3 outputs: 2 Bitcoin to Bob, 0.997 Bitcoin balance to Alice, 1.003 Bitcoin committed to in Alice's HTLC. Alice's balance is reduced by the amount committed to the HTLC. Bob now has a commitment that if he is able to get the secret or within the next 10 blocks, he can claim the 1.003 locked by Alice. With this commitment in hand, Bob's node constructs an HTLC and his payment channel with Carl. Bob's HTLC commits 1.002 Bitcoin to the hash H for 9 blocks, which Carl can redeem if she has a secret OR. Bob knows that if Carl can claim his HTLC, she has to produce OR. If Bob has an OR in 9 blocks, he can use it to claim Alice's HTLC to him. He also makes 0.001 Bitcoin for committing his channel balance for 9 blocks. If Carl is unable to claim his HTLC and he is unable to claim Alice's HTLC, everything reverts back to the prior channel balances and no one is at a loss. The channel balance between Bob and Carl is now 2. To Carl 0.998, to Bob 1.002 committed by Bob to the HTLC. Carl now has a commitment that if she gets or within the next 9 blocks she can claim 1.002 Bitcoin locked by Bob. Now she can make an HTLC commitment on her channel with Diana. She commits an HTLC of 1.001 Bitcoin hash H for 8 blocks, which Diana can redeem if she has secret or. From Carol's perspective, if this works, she is 0.001 Bitcoin better off, and if it doesn't, she loses nothing. Her HTLC to Diana is only viable if or is revealed, at which point she can claim the HTLC from Bob. The channel balance between Carol and Diana is now 2 to Diana, 0.999 to Carol, 1.001 committed by Carol to the HTLC. Finally, Diana can offer an HTLC to Eric committing 1 Bitcoin for 7 blocks to hash H. The channel balance between Diana and Eric is now 2 to Eric, 1 to Diana, 1 committed by Diana to the HTLC. However, at this hop in the route, Eric has a secret, or he can therefore claim the HTLC offered by Diana. He sends or to Diana and claims 1 Bitcoin, adding it to his channel balance. The channel is now 1 to Diana, 3 to Eric. Now Diana has the secret, therefore she can now claim the HTLC from Carol. Diana transmits or to Carol and adds the 1.001 Bitcoin to her channel balance. Now the channel balance between Carol and Diana is 0.999 to Carol, 3.001 to Diana. Diana has earned 0.001 for participating in this payment route, flowing back through the route. The secret or allows each participant to claim the outstanding HTLC. Carol claims 1.002 from Bob, setting the balance on their channel to 0.998 to Bob, 3.002 to Carol. Finally, Bob claims the HTLC from Alice. Their channel balance is updated as 0.997 to Alice, 3.003 to Bob. Alice has paid Eric 1 Bitcoin without opening a channel to Eric. None of the intermediate parties in the payment route had to trust each other for the short-term commitment of their funds in the channel. They are able to earn a small fee, with the only risk being a small delay in refund if the channel was closed or the route of payment failed. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.